Can all of you guys hear me? This is magic. I'm talking, I feel like you're in my kitchen or something because I'm speaking relatively softly. Is the volume okay, or do I need to project more? Volume okay? Wow, this is an amazing technology. Okay, well, good morning. I'm Bill Jacoby, Principal Solutions Architect for Amazon Web Services, focused on enterprise applications. I've been at Amazon for the last 5 years. Prior to that, I was at Microsoft for about 18 years, and I've been playing with SQL Server heavily ever since SQL 2012, and before that, going all the way back to prior to Microsoft buying it, I was playing around with Sybase. So my topic today is designing, deploying, and optimizing Microsoft SQL Server workloads on AWS. I have a lot of content. I think you'll enjoy it, and let's jump straight in. So why are customers choosing to move SQL Server workloads to AWS? Let me just ask you, how many of you are running SQL and RDS today? Okay, a pretty good amount of you. How many of you are running SQL on EC2 today? Okay, so I'm going to go through the pros and cons and talk about both. And before I do that, though, what are the general reasons why people want to run SQL Server on AWS? Probably one of the number one reasons is probably agility. And that's because you can spin up resources very quickly. You can deploy them as you need them. You can deploy tens, hundreds, or thousands of instances in minutes. You can test very quickly. You can succeed very quickly. You can also fail very quickly. Failing very quickly may actually give you more knowledge and more insight into what to do next. Customers also talk about cost savings as a key reason for moving to the cloud. And the thing about cost savings is that you can trade large upfront capital expenses in building out a data center and building out racks and building out servers for variable expenses. And the price that Amazon can provide computing based on our economies of scale is typically much lower than what any customer, even a large customer, would end up paying for computing by the drink. Okay, and we have some customers. We have a customer, for example, Dow Jones, who said they estimate that they save $100 million per year in not having to over-provision and over-purchase infrastructure in their data centers. Elasticity is a common reason for people moving to the cloud. And what this really means is that in the cloud, you're able to get as much demand, as much capacity when you need it as your application requires. And you can scale down on weekends or evenings or whenever your application really requires it. A lot of customers really like our breadth of functionality, in which essentially you have an entire platform of services on which you can build applications. And I'll talk more about specifically like the breadth of functionality around Windows on my next slide. And then the last point is you can deploy globally. So if you have locations in the U.S., in Europe, in Asia, in Latin America, you can deploy single region, multi-region. It's all a few clicks of the console. Okay, so those are some of the reasons why companies and agencies are moving to AWS. In the case of Windows on AWS, there's been a lot of innovation in the Windows space. In fact, I came to Amazon 5 years ago because I was so blown away by how easy it was to take advantage of Windows technologies on AWS. And so we've released all the things that you would assume that we would have released. We've released Windows Server AMIs for all the latest versions of versions of Windows and SQL Server going back over 5 years ago. You can go all the way back, for example, to Windows 2008 and SQL 2008. We also offer, for example, managed Active Directory, and we offer a managed database, the Relational Database Service, which I'll talk about today. We also offer technologies like AWS Directory Service, which provides managed Active Directory as a service, which is a really great service. It's using actual Windows Server 2012 R2 boxes to provide real AD. It's not sort of a ginned up AD or an AD based on an open source product. It's actual AD. We announced FSx at reInvent last year, where we're providing an SMB file system Again, it's an exact SMB file system because it's based on Windows Server. But in both cases, as a directory service and as a file service, we're providing a managed service where you just dial up the performance you want and the capacity you need, and we provide that as a service. We let you dial in how many domain controllers you want, and we take care of things like high availability and managed sites and services and all the things that you need in Active Directory. You just say, how many domain controllers do I need for a given region or a given application? So we're super committed to the Windows workloads, and I'm really excited about all the points of innovation that you see in the slide here. These are probably pretty hard to read, but I don't think it makes sense to go through each bullet point. One of the things that is interesting, though, is the fact that our pace of innovation is accelerating, along with the fact that we're building more and more managed services. Okay, so let's kind of jump into the SQL Server discussion on AWS. And really, there's three areas that I want to talk about here. I want to talk about designing SQL Server, how to design for high availability, how to design for performance, how to design for resiliency. I'll talk about some of the things that go into these different categories, how to migrate to Amazon, and how to manage and optimize SQL Server on AWS. Okay, so where can I run my SQL Server workloads on AWS? I was talking a second ago about the various managed services that we provide, and RDS is one of the best examples of a relational database service in which we provide the management and the care and feeding, if you will, of SQL Server. So you can run your SQL Server workloads on either our managed service, RDS, or you can run SQL Server natively on Amazon EC2. And I'll talk about each one of these. When you run SQL Server on EC2, it's very similar to running it on premises, where you are installing the OS, or will provide an AMI that has SQL Server pre-installed. I should say the AMI includes the operating system as well. But you're fully configuring and managing the operating system and fully configuring and managing SQL Server on EC2, whereas we take a lot of that effort out of it for RDS. So let's talk specifics about these two offerings, RDS and SQL Server on EC2. So I'll start with RDS on SQL Server, and if you take a look at these little sort of yellow slices, I've been told I don't have very good color sense, but I think the background is sort of yellow beige-ish. We provide automatically in the box the ability for you to dial in a level of performance scaling. We build into the box high availability. We use always-on availability groups, and you can sort of check a box that says whether you want single AZ instances of SQL Server or multi-AZ high availability instances of SQL Server, which would be running and taking advantage of always-on. We'll do automatic database backups. You can decide the frequency. You can decide, basically you can decide the frequency of incremental and full backups. We will do full patching of SQL Server, so if Microsoft comes out with patches, we'll apply them. We'll do all of the maintenance that's required for the configuration under the covers. So if we're deploying SQL Server always on, we'll manage for you the listeners, we'll manage the primary, we'll manage the secondary, we'll manage the networking, we'll manage the security groups. So you are really treating SQL Server as a Microsoft product. It is still a Microsoft product, but we're providing the full infrastructure management of SQL Server, all the way down to power, HVAC, and networking. Okay, and DBAs really like telling me about the things that they don't like doing, like why didn't my backup actually run, or how do I add more memory to my database, or how do I go out and procure a bigger server to run my SQL Server. These are the kinds of undifferentiated heavy lifting that RDS takes care of for you. So you can decide when you want to add more memory, if you want to turn on high availability. You can choose when to take advantage of these capabilities on the slide here. I want to be clear, RDS doesn't provide all the capabilities that you get with SQL Server natively. So for example, we do not support at the current moment always on read replicas. We do support always on, we don't support always on read replicas. That's one of the things on our list that we know that's not supported, that customers have requested, and the list is shrinking every day. Another example is if you're running SharePoint, the SharePoint search service requires full SA capabilities. In RDS, we hold on to full SA because we're providing a whole managed service, and we can't kind of share SA with a different application where we have to worry about the responsibility for keeping SQL Server managed and running well. But we are working on all of these issues, and over time, as you saw in my previous slide, we're adding more and more features to both the RDS platform, but also the Windows platform. So one thing that doesn't change, even if you run RDS, you are still responsible for application optimization and tuning. And so there's always a need for DBAs. There's always a need for SQL Server expertise, even if you're deciding to run the managed version. Just like in the case of AWS Directory Service, you can't just turn on domain controllers and provide a NetBIOS name and sort of like lay off the people who do Active Directory administration. You always need to know about what's happening to run efficiently. Now, in the case of SQL Server on EC2, here, the areas in my sort of yellow beige slice tell you what are the things that we provide as Amazon, and all the white slices are the responsibilities that you have as a customer. And so it is the more traditional model of you would be responsible for patching the Windows OS, you would be responsible for adding SQL Server cumulative updates if you want to deploy them. You would be responsible for backups and setting up high availability. All those things that you would do on-prem, you would continue to do on EC2. You're getting full control. You have none of the limitations I mentioned a second ago, but you also have more of the undifferentiated heavy lifting. So I do want to talk, I just want to mention that if I start with the operating system, in the past we've only supported SQL Server on Windows. And starting at reInvent, I believe 2 years ago, we announced SQL Server 2017 running on Linux. And so you now have a choice. We have a lot of customers who really like running SQL Server on Linux. Their main reason, to be quite honest, is for cost reasons. You eliminate the cost of the operating system, which is approximately, in our studies, it's approximately 10% of your total TCO. A lot of customers also like running running SQL Server on Linux because it gives you consistency. If your general application direction is to run more and more applications on Linux, then having your database run on Linux as well gives you the same patching tools, management tools, overall operations tools. And so a lot of customers like the consistency of, if I'm moving towards Linux, let me run my database on Linux as well. And SQL Server, though, tends to be the last thing that still runs on native Windows. And so, but it moves over and it runs well. It does run well on Linux. We've tested the performance of SQL Server on Linux, and in our tests, it is within 10% of the performance of SQL Server on Windows. So the performance of SQL Server on Linux is actually quite good. I've talked to a number of people from Microsoft who have said that they've run benchmarks with SQL Server on Linux, and that it actually, in some of their benchmarks, it outperforms Windows. So, but in any event, it appears to be, essentially in the same range. So so many things are really the same above the OS line and below the OS line. And SQL Server on Linux is, you can see that we support all the 4 editions of SQL Server coming from Amazon. So what are the design choices that you have when you run SQL Server on AWS? These are the design choices that you can make, and we give you these options both on RDS and on EC2. And so you'll have control over all of these capabilities, and I'll sort of dig into this. So let's start with EC2. And where would you want to run SQL Server on EC2 on AWS? What I'm showing you here is a list of all of the instance families that we have on AWS. And Amazon EC2 is designed for any type of computing, more than just SQL Server. The ones that I've highlighted in the middle that are bolded are the memory optimized instances. And we have found that SQL Server applications tend to be either memory or I/O bound. And so, so our general recommendation is to run SQL Server on the X1 family, the R5 family, the R4 family, or R3 family. These are all of our memory optimized families. We also recommend running SQL Server on the i3 family as our storage optimized family. And so I'll talk actually about both of them. And I guess part of what I should say here very quickly is that every workload is a little bit different. I don't know of any SQL Server application that doesn't run better with more RAM. Some SQL Server applications really are I/O bound and not RAM bound. We tend to not see as many applications that are CPU bound. So one of the things you want to do, and one of the themes of of my talk here is test, test, test. Because what will make a SQL Server application run great on AWS really requires understanding where are the bottlenecks and then addressing them by choosing an instance family or network bandwidth or I/O performance. Okay, and you can see that we have a lot of options that are available in the general EC2 world. Let's kind of peel back the onion one layer deeper and look at just some of the options in the R5D family. So the D suffix means that you have locally attached storage. So I'll talk about EBS in a few minutes. EBS is our network attached storage. And so when you look at these instances in the R5 family, this means that they are memory optimized, which is good, and they also have local instance storage, or they also have local storage, and I'll talk about that in just a second, how that helps SQL Server. So I guess the first thing that may jump out at you when you look at this table is you may say, hey, I would love to have 128 gigs of RAM. I don't know if you can see my cursor here. You cannot. You may say, I want 128 gigs of RAM, but I don't actually need 16 vCPUs. So you may say, well, I want to move one attribute up and maybe move another one down. And so you have this ability on AWS. So this is a general family, and this R5D family. You can choose. You can see what the basic characteristics are. But let's say that you want an example where you want 128 gigs of RAM, but you don't need those 16 CPUs. Okay, so here is an example where, in the case of you can take the R5 4XL, and it comes. So in this case, the R5 4XL comes with 16 CPUs. And if you say that all you really need are 8 CPUs based on your workload, what that does is it allows you to bring your own license, turn off 8 CPUs on Amazon EC2. The instance will only the instance is hard partitioned, so any auditing or assessment tools that are looking at this instance will only see 8 vCPUs. And by doing this, you only need to license SQL Server for 8 CPUs. In other words, giving you 50% license savings. Or if you have another example where you wanted the amount of memory that comes in an R5 12 extra large, which I believe is 128 gigs of RAM, but you only need 8 CPU, you can take the R5 12XL and you can say, I would like to only turn on 8 CPUs. And in both of these cases, you're using a feature of ours called Optimize CPU. And Optimize CPU allows you to control the number of vCPUs that are active. Again, hard partitioning. SQL Server and the operating system will not have access to any more than what you enable. And you can also enable or disable hyperthreading, both of which have an impact on many software license agreements. So how do you use Optimize CPU? It's actually really simple. You just pass in 2 parameters. When you're using the run instances CLI command, the 2 parameters are core count and threads per core. And you just pass in my total core count of 8 and threads per core of, say, 1. Okay, and then you've now cut down and you can take advantage of, say, the larger RAM, but a smaller number of CPUs. Okay, you don't have to believe me. And when I talk about the savings here, this is an example of a customer of ours called Cloudhesive, and they talked about the fact that they really got 50% license savings when they took advantage of optimized CPU. Okay, let's. So that's a little bit of the CPU aspect of CPU and RAM aspect of running SQL Server on AWS. Let's talk about database backup and storage options. We actually have a lot of storage options, and every option has a different combination of performance, durability, cost, and interface. And so if you're looking to run SQL Server, we think of basically two types of storage, EBS storage, which is network attached storage, and instance storage, which is locally attached storage. And I'll talk about both. I'll talk about both of them here. I'll also touch on Amazon S3, which we recommend, which is our object store, which we recommend for backups. Okay, so like I said, EC2 Instance Store are volumes that are directly attached to the instance. And so in a couple slides, I'll talk about the performance that you get by having directly attached storage, and Block Store, which is network attached storage. So let's dive into this a little bit more and see how these storage types would relate to SQL Server. So if we want to drill in a little bit, you basically need to store your SQL Server data files and your log files on some kind of fast storage. And your two options are either Instance Store or these EBS-backed, the recommendation would be EBS SSD-backed storage. And so, I'll talk a bit about each one, but basically data and logs need to be very fast. And data and logs are obviously on your application's critical path. They don't have to be, you don't have to use the same volume for data and logs. If you have a write-sensitive application, the logs may need higher I/O performance than data. The local instance store, for example, the i3 instance, which I'll talk in more detail about in a minute, provides extremely fast storage. In the case of EBS, we do have two types of EBS volumes. We have the EBS SSD-backed volumes, which is listed right here. We also have EBS volumes that are backed up by hard disk drives, which are great for things like backups, where you don't need the throughput and the performance of SSDs, and frankly, you can save money by using hard disk backups, hard disk drive backed volumes. You can also do backups directly to Amazon S3, okay, which will save you a lot of money. So, okay, so I've kind of shown you on this slide what I think you should use, but I haven't really dived into these two different options. So let me dive into like the two options of EBS in a little bit more detail. So EBS, first of all, is network attached block storage. Like all AWS services, you only pay for what you use. Basically, EBS is like having your own SAN, but you're only paying for the amount of the SAN that you actually need. You have built-in redundancy with EBS. You have built-in encryption with EBS. And many customers decide that they want to use EBS encryption instead of TDE, transparent data encryption inside the database. TDE is a SQL Server enterprise feature. So if and it's one of the key features that's driven customers to move to SQL Server Enterprise. If you're only moving to SQL Enterprise for encryption, there's no need for that. You can take advantage of encryption at a volume level. Another key aspect of EBS is that you have elastic volumes. What I mean by elastic volumes is you can change the size of your volume on the fly. So if you're running out of, if your volume that holds the log files is running out of space, you can issue a single call and you can elastically enlarge or if you needed to, decrease the size of a volume. And so that's another one of the really nice capabilities of being in a cloud environment. Let's see, I should mention, I was going to say something about licensing, but I think I'll hold off on licensing. And so essentially, this is the story of EBS, and EBS is one of our recommended storage options for SQL Server. But you've got to be careful with EBS storage, and you've got to be careful with EC2 and EBS storage. So there's one more limit. It's not just a question of what is the performance that you get with an EBS volume. So in my example here, let's say that you have a 2 terabyte EBS GP2, general purpose 2 volume. The way you calculate the number of IOPS on a GPS volume is it's 3 times the number of gigabytes capacity. So a 2,000 gigabyte volume would have 6,000 IOPS that volume could produce. Now, having said that the volume will support 6,000 IOPS doesn't mean that you'll actually receive all 6,000 IOPS. Your actual throughput requires CPU that's strong enough to be able to drive the storage subsystem at that speed. So in my example on the slide here, where I have an M4.large, the M4.large with 2 vCPUs is only able to drive actually about 56 megabytes per second of throughput versus the 160 megabytes per second throughput that the storage subsystem by itself could support, sort of independently of what microprocessor is accessing it. And so I have a follow-on example here where if you use an M4 2XL instead of an M4 large, then you get a 1 gigabit per second network connection to your storage, and that 1 gigabit network bandwidth to storage gives you about 125 megabytes per second throughput, and that 125 megabytes per second is almost saturating the 160 megabytes per second throughput that the storage subsystem allows. So when you're planning for SQL Server, you want to be aware of the fact that you have capacity and storage capabilities at the storage level, but you also have capacity limits that are imposed upon you by the Amazon EC2 instances that you've chosen. So in this case, an M4 2XL is a better choice if you want to actually achieve that 6,000 IOPS of throughput. Okay, so what about Instant Store? I mentioned that Instant Store is direct attached storage, and you can think of Instant Store as just like a disk in your server at home, or if you're a person like me and you have servers at home or in your data center. It can be an SSD or it can be a spinning disk. Direct attached storage has super low latency, and it doesn't come with all the benefits of EBS. So there is no encryption unless you go to extra effort to perform these things. Amazon doesn't provide encryption at rest with instant storage. We don't provide automatic snapshotting of instant storage, nor do we provide automatic storage level replication like we do with EBS. I don't remember if I mentioned it on my previous slide, but EBS is inherently redundant. When you write to an EBS volume, without you having to do anything special, you're actually writing to multiple EBS volumes for redundancy. And if you were to lose a disk, you would actually not lose a disk. We'd provide the same the same data back to you, and we in the background would actually replace the disk. So you have redundancy with EBS. You don't have redundancy with Instant Store, but you do get blazing performance. And so there are ways to overcome some of the limitations of Instant Store, and a lot of customers who are running SQL Server and want the best performance specifically want to overcome these limitations because it'll give you by far the best experience with SQL Server. And I have an actual customer example coming up where I'll talk about a customer putting their SQL Server data files and their log files both on Instant Store, and I'll talk about how to overcome these limitations. I want to be clear though about Instant Store. If you do a reboot of your server, you don't lose any of the data on this ephemeral volume. Instant Store and ephemeral storage are synonyms. And so normally you might think, well, I don't want to use anything that's ephemeral. If I use something ephemeral and there's an application crash, I've lost important data. So you can address that issue either with building in high availability at the Instant Store level, and I'll talk about how to do that. You can also use Instant Store. So you can. Oh, and I started to say you also don't lose data if you reboot your machine using Instant Store. It's only if you stop your machine and then later on start it. So it's a little bit of a nuance, but for many use cases like patching, you wouldn't lose your data. But this is sort of a big topic, and I want to talk more about how to use Instant Store so you can take advantage of the performance gains that you would receive. Okay, so what are some good use cases for Instant Store? Well, the first and obvious one for SQL Server is TempDB. TempDB will be recreated even if you completely stop and start your SQL Server instance. TempDB will be recreated on the fly. So TempDB never has data in an actual data file. SQL Server or Instant Storage will support very low latency, like I say in my slide here, 0.1 milliseconds, with extremely high IOPS. So if you look at EBS optimized for this R4 instance, you would get approximately 80,000 IOPS out of your network attached storage. You can get over 3 million IOPS using Instant Store. And so your throughput as well is almost 10 times what you can get with EBS and network attached storage. And so in general, we see customers using EBS for SQL Server, and putting TempDB on Instant Store is sort of a no-brainer. Putting TempDB on these NVMe SSDs is a really great way to improve performance. And you can get larger size instance stores with the D2 instance type and the i3 instance type. Okay, so I'll talk about some specific use cases and a customer example for using Instant Store. And by the way, again, you don't have to believe me. We talked to Infor, and the guys at Infor. Actually, in this case, I want to talk about backup. So the guys at Infor talked about using S3 for backups, using either ST1 for backups or S3 for backups. ST1 is our network attached EBS volumes, but they're backed by spinning volumes. They're not backed by SSDs, and so ST1 is much cheaper than SSDs. ST1 is much cheaper than GP2 and IO1, and it's just fine for performing backups. We also have EBS IO1 storage types, and IO1 allows you to dial in the specific performance characteristics that you need. And so with IO1, you dial in a specific throughput that you want from the storage subsystem, and we will guarantee that 99.9% of operations against IO1 are within 10% of the value that you dialed in over the course of a year. And so IO1 is a higher performance EBS choice than even GP2. So the hierarchy is sort of GP2 for greater performance, IO1. Instant Store is even better performance. ST1 is the lowest on the spectrum, and that's what we tend to recommend for backups. And I started to mention Infor talked about saving money on their monthly backup costs by using these ST1 volumes. They said they saved 75% of their monthly backup costs. Okay, so I've talked about the OS, and I've talked about things below the OS like compute and storage and networking. And so let's actually pop up in the stack a little bit and talk about how to configure high availability and disaster recovery on AWS. Okay, so if I jump right into it at a high level, this is what an availability setup would look like on SQL Server. You have essentially two nodes here. You have two nodes here, a primary and a secondary, with synchronous commits between the primary and the secondary, and you get automatic failover as a result. These two nodes that I'm showing on this slide are in two different availability zones in a single region, and typically there's less than 2 milliseconds of latency between availability zones in a region. And what that means is that when your application writes to the primary, it'll write to the secondary in the other availability zone before reporting success to the application that's performing that write. Okay, and I've talked to lots of customers who have used Always On, but in a traditional data center environment where they put one SQL server at one end of the data center, their secondary at the other end of the data center. and then some event happened like air conditioning going out, which took out the entire data center, and essentially you didn't have high availability, even though you had set up always on, on racks that were very far apart from each other. And so, so with multiple availability zones per region, you're close enough to achieve very low latency, and in the case of AWS availability zones, these are separated by miles, and they have separate power. They're on separate floodplains, and they have separate ISPs. And so you can have a significant, catastrophe in one availability zone, and it won't affect another availability zone, with on average less than 2 milliseconds of latency between the two. So this is a really great use case for SQL Server and for high availability. And the recommendation is that you put your always-on nodes in different availability zones, and you put your witness in a third availability zone. And this has really been game-changing for many organizations, and some organizations are using this configuration for both high availability and disaster recovery. However, some customers want disaster recovery across regions. Being separated by miles isn't enough. They want disaster recovery across 500 miles, which is typical of government, or even more. And so, and there are natural disasters that span hundreds of miles. So it's totally legitimate, I think, to say I want disaster recovery across many hundreds of miles. So in this case, what we're doing here is we're deploying an always-on availability group in region A on the left. And this is the same architecture with synchronous commits between the AZs and automatic failover. And I've configured, or you would configure asynchronous commits to the second region, which would require manual failover. So when you have asynchronous commits, what that means is that that the database on the other end of the replica that's receiving asynchronous commits will be some number of seconds behind the database on the primary. And so there will be some amount of data loss should there be a catastrophe that takes out region A in my diagram here. And so when you set up a DR strategy, you really have two main measures: your RPO, your recovery point objective, how much data is it okay to lose, maybe seconds worth of data. You also have an RTO, a recovery time objective, which is how quickly you're able to get back up and running. So this will allow you to support very low RPOs and very low RTOs. And but with asynchronous replication, it does mean that you'll incur data loss. You'll have a non-zero RPO in this environment, but it'll be very low. And so we're really just using the SQL Server always-on availability group, cross-region asynchronous replica for DR. And it will be lagging by seconds, but you should really, this may vary by your workload. Okay, so this is a recommended architecture, and we have many customers who have set up exactly this. Okay, Microsoft came out with a similar concept called distributed availability groups in SQL Server 2017 Enterprise Edition. And there's a lot of similarities between what Microsoft came out with and what I described on the prior slide. So in-region replication would still be across multiple availability zones and is still synchronous, and cross-region replication is still asynchronous. And this is taking advantage of Microsoft distributed availability groups. Okay, always-on availability groups is a really great replication technology. It's probably, in my talks with Microsoft people, I think always-on availability groups is really considered to be the gold standard for high availability. But it's not the only one. So I should mention, by the way, that SQL Server Standard Edition has basic availability groups, where there's one availability group per database, which can be difficult to administer. And so there's another technology called failover cluster instances, or usually shortened to failover clusters. And this is where you would fail over not just a single database to a secondary, but you would fail over all the databases running on your SQL Server instance to a secondary replica. And the way this is typically implemented is with shared storage. Now, in order to implement shared storage in the AWS world, you would need to set up data replication between the EBS volumes running your SQL primary in one availability zone, and replicate the storage to an EBS volume in a second availability zone to take advantage of failover cluster instances. Okay, and so there's multiple technologies for performing data replication. You can use NetApp Cloud on Tap. You can use Sios Data Keeper. Microsoft provides their own kind of software-based replication technology, Storage Spaces Direct. And so there's a whole number of ways of performing block-level replication, which from an operating system and a SQL Server perspective looks like shared storage. And so this is the way that many of our customers have implemented failover clusters, failover cluster instances on AWS. And once you've set up replication at this level, it's really not so different from the prior architectures. So if you rely on storage level replication, things like logins and jobs are kept in sync at no additional administrative cost. You do have to pay for a third-party tool to establish replication. Okay, and let me talk about an actual customer who has implemented a number of the technologies that I've been talking about so far. Okay, so if I look at this customer, Sonos makes high-quality wireless home audio products. They're really great products. I'm personally a user of their products, and they work across fairly big homes, and they're really nice products. So Sonos uses SQL Server, and the first point that they really make a note of is that their bottlenecks have always been, like other customers, they say their bottlenecks have been memory related and IO related. They also have a requirement for DR and for HA, and they make a big deal about needing to test backups. The customer, the Sonos CIO that I was talking to made a big deal of saying, you can't depend on servers not to crash. You've got to have a real strategy. Okay, so you've got to test your backups, and you've got to figure out what are your bottlenecks and test your backups. Okay, so their first attempt at running SQL Server on AWS, in order to get 40,000 IOPS, they had to stripe together 2 large EBS volumes for a relatively small database, and they needed a relatively large EC2 instance to get the required throughput that they needed. And they ultimately decided that this wasn't cost efficient. And so they wanted to move to, they did, however, set up Instance Store for TempDB, and they did set up an availability group with SQL Enterprise. And what they learned at Sonos is that this was expensive, that IOPS really matter, that whole point about IOPS at the storage level versus IOPS at the database level. And they determined that you've got to be really careful to make sure you get the right EBS optimization throughput. So they jumped to ephemeral stores, and ephemeral stores, to recap, are faster. They're also cheaper because they come with the instance. They're actually cheaper than EBS volumes. They're about a third the cost, using ephemeral volumes instead of using EBS volumes, which you pay for per gigabyte. The ephemeral volumes are included in the cost of the instance. The disadvantage, like I said earlier, is that instance stores are lost on a stop-start operation. They're not lost on a reboot, but they are lost on a stop-start. Okay. Sonos is also running SQL Server basic availability groups to save money. Okay, so Sonos currently is running i3s. The i3s all come with very fast instance store, and they're putting their user databases on ephemeral storage, and they're seeing over 100,000 IOPS with nearly zero latency. They're also storing their backups in S3 for each database, and basically their job was to mimic always-on availability groups. So they set up always-on availability groups to provide redundancy for instance store using the availability group construct. So they took away the fact that we don't have redundancy at the instance store level on AWS, and they built in redundancy at the SQL Server level. And in their mind, they were able to take advantage of the performance of NVMe locally attached instance storage and lower cost and they remediated the issue of redundancy by using always-on availability groups. So this was their solution, and they did some testing to show just how much better this solution would be. So they discovered that there would be quicker reads, quicker writes, and lower latency using the i3 versus the R4. They ran disk speed, which is the typical test for testing I/O in SQL Server, and their configuration was what you see on the slide here. And the results are what you see in this table. This table is a little bit hard to read, but if you look carefully at this table, the table is divided into reads, megabytes per second, IOPS per second, latency, and then writes of megabytes per second, or throughput, IOPS, and latency. And if you look at the I3 columns and the R4 columns, you can see that, for example, in the case of read IOPS, it was mostly the same between R3. I'm sorry, it was like 10x between R4s and I3s. If you look at average latency was 0.3 milliseconds for random 8K blocks, 0.3 milliseconds with an i3 versus 2.4 seconds read latency on the R4. If you jump over to writes, with the i3, you were able to write 48,000 IOPS, and you were only able to write 12,974 IOPS using the R4. So the i3 was much more performant for reading and for writing. And again, the latency for writes was 0.6 milliseconds versus 2.5 milliseconds. So they basically said, we're getting the better performance and we're taking advantage of always on for high availability. Okay, and so like I said, they used availability groups for both enterprise and standard. They were able to use core optimization to save money as well. They used the trick that I talked about in the beginning of my session of disabling some of the cores in order to save money on SQL Server licensing. The distributor, they used an M3. The distributor can't take part in an always-on availability group. They used the instance type X1E for analysis services, and they're using S3 for backups. So this was kind of the set of Sonos's best practices. Okay, and their overall theme or feedback was similar to the overall theme that I've been talking about throughout, which is test, learn what works, and then iterate, and really focus on these areas like IOPS and throughput and how many cores do you actually need and so forth. Okay, so just a few tips and tricks for running SQL Server on Amazon EC2. Like I've been saying, do lots of testing, set up high availability for production workloads. You can use both always on and failover cluster instances. If you use failover cluster instances, you do need a replication technology. Storing your backups and your audit logs in S3 will save you a lot of money, okay? Because S3 is an order of magnitude cheaper than EBS. We recommend performing nightly backups and incremental backups for point-in-time recovery. And something interesting that you may not be aware of is you have sort of the option of two different types of SQL Server backups. You can do native SQL Server backups either in RDS or on Amazon EC2. However, if you're doing native SQL Server backups, you have to go through a little bit extra work. On EC2, you can just take storage snapshots, and SQL Server is VSS aware and will create crash-resistant, consistent snapshots. So rather than actually backing up your database, you can just take a snapshot. You can just take a snapshot of the volume, and the files that are on the volume will be. You can fully restore them, and have a fully restored database. The last tip and trick for Amazon EC2 is that I've talked about like R4s. In general, as you look at newer instance types from Amazon, they tend to be both faster and cheaper. And so if you've been using, say, the R3s, you'll lose nothing by moving to the R4s, and they are both faster and cheaper. Okay, and let's see. RDS is very similar to SQL Server, where except we provide always on in this example as a managed service. Tips and tricks for RDS are very similar to the tips and tricks for AWS. So choose the newer instance types when you choose the instance types for RDS. We have lots of customers, and our process is very well documented and works very well. And so we have a number of tools for migrating SQL Server to AWS, and we have a whole separate session on migrating SQL Server to AWS. So I'm just going to sort of highlight some of the key ones here. There's backup and restore. There's also the database migration service and schema conversion tool. These tools help you do backup. They also, by the way, help with just replication. Okay, and just some other things to be aware of are you can monitor SQL Server with RDS. RDS provides enhanced monitoring. Information like OS level metrics, CPU, disk I/O, memory are all stored with up to 1 second granularity in CloudWatch. We also have an agent that you can put on your RDS instances, and if you use the agent, you can get up to 1 second granularity. Okay, so you can get a lot of monitoring of RDS on AWS. We provide encryption. You can either use encryption at the database level, or you can use encryption. You can force encryption through the connection string and use SSL. Okay, and you can audit any sort of creation of databases. You can audit create database, modify database, delete database instance, and you'll have a record of who did what with your SQL databases. Okay, and then finally, in terms of compliance, there's lots of compliance capability or compliance regimens supported for SQL Server. We're in the process of a JAB review for SQL Server for both FedRAMP Moderate and FedRAMP High. SQL Server is being evaluated for FedRAMP Moderate in the US East and West regions, and SQL Server is being evaluated for FedRAMP High in the GovCloud regions. Okay, so we're having the JAB is looking to give us our final FedRAMP authorizations. Okay, and so that's what I had today on SQL Server. I hope that this was an interesting session, and thank you for attending.